Hey guys, now I'm trying to learn increasing and decreasing functions, critical points versus stationary points, and etc. So I've been taking some notes, but now I record this video. So basically, what is increasing and decreasing functions? Increasing function is that x1 is greater than x2 and fx1 is greater than fx2. It means that our function is increasing, but x1 is, let's say, greater than x2, but if x1 is less than fx2, that will be decreasing function. That is the basic rule that we learn in functions. But what about derivatives? For derivative, it's pretty simple that if derivative of f of x is greater than 0 at every x, for every x in AB points, that will be the increasing, and f of x, derivative of f of x, is less than 0 at AB points for every x, that will be decreasing function. What about the critical points? Okay, critical points, my teacher, that's my teacher's note, but basically critical point for me is that, let me show you this thing, in which value of x derivative of function is 0. So which values of x makes function 0, that is stationary points. How do I remember that? It's like imagining like that is our boss. Sorry for terrible drawing, but that's our boss, and it stays in here. It cannot go further or back, not like this, not like this. It just stays here. Okay, for me that is, and that point is 0 point, okay, because it doesn't move. But critical points are, it can be every point, okay, this place, this place, this place, but not all stationary points are critical points. There is difference. If we want to find stationary point, we will apply this thing. So for which value of x, the function will be 0. But all roots of the function is critical points. Okay, that's so easy. Let's see example, and that is my teacher's example. Okay, let's try to do this one. F of x equals to x squared plus 4. Sorry. Okay, x squared plus 4 over x. By the way, I'm just trying to learn this topic. I can make so many mistakes, and whenever I don't understand something, I will ask AI. I just want to inform you because I am a learner and I just want to share my learning process with you. Okay, x squared plus 4 over x. We need to find the derivative. Is they have anything? No. Okay, we need to find the derivative of that function. Derivative rule is like this: x squared plus 4 derivative times x minus x squared plus 4 times x derivative over x squared. That is our formula, and let's simplify it. What is the derivative of x squared plus 4? So 2 will come here, 2x, and 2 minus 1 will be 2x, okay? I hope that we know how to find derivative. So times x minus x squared plus 4. I hope I don't make any mistake. Derivative of x will be what? 1 will come here, and that will be just 1. Is that true? I don't know. That will be 1, okay. So over x squared. I don't want to, okay, that will be x minus 4 over 4x, and the derivative of x will be x squared minus 4 over x. Okay, and now in order to find the stationary point, and critical points, we need to make f of x equals to 0. So we will do the same thing. We will do x squared minus 4 over x will be 0. Is that true? My solution, is that true? Yeah, that's true. That's true. Okay, let's continue. X squared minus 4 over x will be 0. Basically, we know that x minus 2 is 0, x plus 2 is 0, and x equals to 0. x2, negative 2, and 0. So in which value our function will be 0? Let's find it. If we put x 0, 2 here, okay, 2 here, 2 squared minus 4, 0 over 2. So it will make our function 0. So 2 is our stationary point. Stationary point. Yeah. If it's negative 2, it will be again like this. That's also stationary point. Stationary point. But what about this one? This is negative 4 over 0. That is critical point. Okay. By the way, I just want to note that all the roots are critical ones. So this is also critical. This is also critical point. But 2 and negative 2 are stationary points. So we have roots, okay? Let's do this right. So in that context, we have maximum and minimum points. I will explain. So my teacher explained that, and I'm just trying to explain this to myself. So we have something like this. So we need to write the roots. Negative 2, 0, and 2. It will be like this. Sorry. Oops. Yeah. So it will start from the positive. Yeah, true. Negative, positive, and negative. What is the maximum point and minimum point? If we start from, it will be like imaginary. If we start from the here and increased from the here to here, if we start from minimum, and or how can I express this? I don't know. If we start from left and go to the through the right, this point will be our minimum point, okay? But if we start from the here and go through here, it will be our maximum point. If I'm not mistaken, let me see. Yes, critical points are true. Critical. Okay, non-differentiability. All right. Yeah, it's stationary point. All right. So if we come from negative to the positive, it will be our, yes, that's, let's say that's negative. Through the positive, it will be our minimum. And if we go from positive to negative, it will be our maximum. I remember this and I memorize this like this. So yeah, what is this? Non-differentiability. F of x doesn't exist as x equals to 0. That's true. So that's why we only have 3 critical points. Okay, we didn't need this one. We understood maximum and minimum points. So we have another example here. Let's try to do this one. Okay, what is our example? F of x equals to x cubic minus 6x squared plus 1. And we need to find the things, okay? I'm just gonna try to do that by myself. Derivative of this function, derivative of f of x will be 3x squared minus 12x. And in order to find stationary points, we need to do this thing, okay? So it will be 3x squared minus 12x equals to 0. So 3x, x minus 4 will be 0. What are our roots? 0 and 4. So let's define what is our stationary point. Stationary point is 4. If we plug 4 into this place, it will be 0. Yeah, it will be 0, so that's why that is our stationary point. What about this one? If we put this to here, stationary point, both of them are stationary points, yeah. If we plug 0 to here, that will be stationary as well. Stationary, and they are critical also. That's also critical. / critical. So in order to find maximum and minimum and in which intervals they are increasing or decreasing, we will do something incredible. So write the roots 0 and 4. It will be like this. Wait. Oops. Positive, negative, and positive. Okay. If we start from positive and go through the negative, imagine like this. We start from the positive, and this is also positive interval, and go through the negative. That will be our maximum point. What about 4? If we start from negative and go through positive, if we start from the negative, it's negative, and go through the positive, it will be our minimum point. I hope that's true. Yes, that's maximum, and this is minimum. All right, what about increasing and decreasing? So our increasing intervals are so easy. It's really easy. It's like doing now I will tell it, but let me write first. Negative infinity to 0, 4 to positive infinity. What about decreasing? It will be 4 to 0. Sorry, from 0 to 4. Okay, something like this. What about, that's true, yeah. What about f, another example? Okay, f of x equals to x cubic. Let's find the derivative of this function. It will be 3x squared. Okay, and we need to make this 0 to find stationary points. It will be 3x squared will be 0, x squared will be 0, x will be 0. Okay, we have 0. Okay, that is 0. But if that is x squared, it means that both sides will be the same mark. If it's the positive, that will be positive, and if it's negative, that will be negative. But so coefficient of our x squared is positive, and there is nothing negative in this function. And if we put negative number, that will still be positive because of the even power. So that's why both sides will be positive. That is our rule from the inequalities, if you remember. It's like doing inequalities, really. It's really enjoyable. All right, what about our maximum and minimum points? So it starts from positive and it goes to the positive. It means that we don't have any no maximum and minimum points. Okay, just remember it. Let's do this one. It seems really interesting. F of x equals to x cubic plus 3x squared plus 5. Firstly, find the derivative of this function. It will be 3x squared plus 6x, yeah, and it will be 0, x plus what? 2 will be 0, x 0, x1 0, x2 negative 2, negative, so stationary point, and that is also stationary point. They're both critical and stationary points. Okay, let's write our roots, negative 2 and 0. Oops, that will be positive, negative, and positive. It starts from the positive and go like this. That will be maximum point, and from the negative to positive it will be minimum point. Our increasing interval will be negative infinity to negative 2 union with 0 to positive infinity. What about decreasing? Negative 2 and 0. All right, I hope it's true. Yeah, that is true. So good. Maximum, minimum. Yeah, let's do this one. Another example. Okay, f of x equals to 2x cubic minus 15x squared plus 24x plus 8. Okay, all right, we need to find the derivative of this function, 6x squared minus 30x plus 24. It will be 0. Okay, it will be 0. So if it will be 0, let's divide all of the sides to 6. It will be x squared minus, is that true? Yes, we are going very well. X squared minus 5x plus 24 over 6, 4 and 1, 4 and 1. What are our roots? 1, 4. Okay, so it will be what? X minus 1, x minus 4 equals to 0, x minus 1. It is positive, negative, positive. This point will be max, this point will be minimum. Increasing will be negative infinity, 1, 4, positive infinity. Decreasing will be 1 and 4. Okay, that was too quick. So we have the second derivative test. Okay, now sorry for the interruption. Okay. All right, what is our second derivative test? It will be really entertaining. So, you know that we have a right to the secondly derivative. Finding the second derivative of the function, isn't it? So if it is gonna be greater than the 0, that will be our minimum. Okay, that will be the minimum, but the second derivative of x will be less than or 0. It will be our maximum point, and we will prove it with what? You will see, with the first derivative test. That is our first derivative. The things that we were doing were the first derivative. Okay, they were first derivative, and I want to prove the same thing. So basically we will apply second derivative test, then I will prove you that it's also true in the first derivative test. Okay, how was it? Let's say that, what's our function? Second derivative of f of x, 0, 3x squared minus 12x. So my teacher, basically, I remember that he took example from that place. So we took the first derivative, and that is the second derivative of that exercises. Okay, it will be 6x. Yeah, that was another example. Okay, I don't want to confuse you, so that's why let's find that one where root was 4 and 0. Yeah, in that. Okay, it will be a little bit it could be a little bit confusing for you, but it's actually the same thing. Okay, that is the same thing. We have done this one, and my teacher didn't want to rewrite all of those things, so that's why he did like this. Okay, but for no confusion, I will restart everything. Okay, what is the first derivative of our original function? It will be 3x squared minus 12x. What is the second derivative of our function? That will be 6x. Okay, what are our roots? We found our roots. Yes, what are our stationary points in this one? Our stationary points were in our first derivative, whereas f of x will be 0, 3x, x minus 4 will be 0, x 0, and x2 is 4. Okay, so our points are them. In our second derivative test, we will basically use those points. So 6x is our function, and it will be 6 times 0. It is 0. What about the other one? 4. 6 times 4, that will be 24, and it's greater than the 0. Yes. That will be our, if it is greater than the 0 for the second derivative test, it will be minimum point, and this one will be our maximum point. Yes, let's write this one. Oh my gosh, it seems really terrible. I don't know if I could do this one or not, but let's learn it. So it's our aim to learn it. Fx sine x plus square root of cosine x. We will do this for the, which one? Second derivative and the first derivative. Okay, let's do the first derivative one. Cosine x plus negative sine x, negative sine x. If we divide both sides, I mean everywhere, to the cosine, it will be divided by cosine x. Cosine x over cosine x will be 1 over sine over cosine will be tangent x. Okay, for the stationary points, we will make it 0. 1 over square root of 3, tangent x will be 0. Tangent x will be what? Square root 1 over, yes, 1 over this one. In which degree? Our tangents will be like this. Let me remember. Which degree was it? It was at pi over 6. No, that is pi over 3, if I'm not mistaken. No, that was pi over 6, yeah. That was in pi over 6, and as you can see, that is trigonometric equation, so we need to imagine it. That tangent x is 1 over square root of 3 in 30 degree. Yes, it is 30 degree. So where, as you can see, that is tangent is positive, so it means that our tangent is here, and where tangent is positive, here, that will be negative, positive, that will be negative. Here is negative and negative, it will be positive. So 180 plus 30 degree, basically pi plus pi over 6, and it will be 7 pi over 6. So in 2 points, in those 2 points, so x1 will be pi over 6 and x2 will be 7 pi over 6. In those points, that is the roots of our function. So what is next? What's next? We want to check them. Okay, we find them. We find let's do second derivative test. So we have 2 points, yes, and second derivative of this function is what? So first derivative of our function is 1 minus square root of tangents x. Okay, so second derivative of this 1 will be 1 will disappear, negative wait a second, it will be like what? Negative times, what is the derivative of tangent x? 1 over cosine square x. It's the second, but I prefer like this, cosine square x. All right, so what is, I hope that I'm writing that correct, negative cosine square x and 7 pi over 6. Is that true? Let me see. 3 cosine x, 1 over sine x. What? Wait a second. What is a cosine? Alright, I am confused a lot. Wait. Okay, the first derivative is this one. Okay, what is our first derivative? Just remember. What is our first derivative test? Cosine x minus... What was our first derivative? Wait. Cosine x minus... Oh, shit. Okay, wait a second. That won't be like this because I simplified it and I divided both sides to cosine x, but that is the version that we needed to do. Yeah, that is original function. This one is first derivative, and in this one we just divided both sides to the cosine x. So our second derivative, cosine x minus square root and cosine, what is this, times sine x. Okay, so what is the second derivative of this function? Cosine will be negative sine x. Okay, and I hope that's right. I hope that is right. Let me see, where is the second derivative? Yeah, is that true? Negative sine, yes. So, and we will plug them. Firstly, we will plug pi over 6, and then we will plug 7 pi over 6. Okay, what is that? Is basically 30 degree. Negative sine 30 degree is 1 over 2 minus cosine 30 I think that's true. And what about this one? It will be in the third quadrant. That is our cosine, and that will be negative, by the way, and our sine will be negative as well. So it will be what? And that's our original, by the way, don't forget this one. Negative sine x will be negative 1/2 in this degree, yes, minus square root of 3 times sine x. Sine x will be negative, yes, okay, 7 pi over 6 will be 1/2 plus 3/2, that will be 2, and this will be what? Okay, that will be what? Negative 1/2 minus 1/2 minus 3/2. That will be negative 4/2. That will be negative 2 and 2. Is that true? Yes, we didn't basically need to calculate. We just need to measure that. Is that maximum or minimum? In the second derivative one, if it is negative, that is maximum, and if it is positive, it is minimum point. Don't forget. Okay, and we have concave up and concave down. It was a little bit complicated for me, so that's why I'm gonna use YouTube. Concave up and concave down. Oh my gosh, that's my calculus notes here. Yes, and concave up and concave down. What is this? Concave up and down. If the second derivative of function is greater than the 0, that will be concave up according to the notes. If it will be less than, it will be concave. Oh my gosh, my writing is terrible. Concave down. All right, up and down. And that was the end of the lesson. I was somewhat distracted, so let's see, do we have anything? Concave up and derivatives. Concave up. Oh my gosh, concave. Yeah, that's here. We have, yes, inflection point is over there. Concave up here on like this. Wait, I don't wanna write, but we need concave up, concave down, inflection point, and first derivative test. They are just not this one, but we just need concave up and concave down and inflection points. So I'm gonna watch organic chemistry tutor. Maybe this video could be enough for me, because I don't want to lose my time by watching this video, because we did them. Okay, we don't need, I just need this one.
The second derivative is positive, which means that the first derivative is increasing. When it's
Okay, well done. That is short video, but I want to write what I've learned so far. Let's say we have something like this, plus 7x. And I'm gonna try to do this by myself. No, wait a second. Yeah. So firstly, let's find the first derivative of this function. What about the second one? Sorry, that will be plus 7 will be like this. What about second derivative? 6x minus 18. That is gonna, if we want to try to find inflection point where it's 0, we need to make this 0. 6 times x minus 3 is 0, and x will be 3. So that's our inflection point. Inflection point. And again, we have what? Okay, that's our 3, so positive or negative. So if we, let's simplify it like this in here. Okay, if we put positive number like 4, and which is next to 3, that will be positive. Okay, and if we put negative, it will be negative. That's positive, and this one negative. So our inflection point is 0. Our concave down, concave down, and that will be our concave up. Okay, so that will, concave down will be negative infinity to 3, concave up will be 3 to positive infinity. Very good job. What's our inflection point? That is equals to 3. Well, what about the other?
Now notice that
Example, by the way, I think it will be like this. So let's say we have 3, it will be like concave, sorry, down. What is the meaning of down? It means that it will like this. Down, if it's positive, it will be up. Down, yes. Negative, it will be up. Okay.
the concavity changes. If you do, 3 is 27. Negative 33 for the f of x is x to the 4th.
What's
33
this?
for this.
Hi, I'm an AI. I can trade.
Negative 33 for this problem.
Okay.
So you can write that as an ordered pair. Now let's work on another problem. So let's say that f of x is x to the 4th plus 4x cubed plus 1.
Let's do this by myself. Let's find the first derivative of this function. It will be 4x squared plus plus 12x squared. Second derivative of this function will be 12x squared plus 24x, and make this equals to 0. 12x times x plus 2 will be 0, x0, x1, 0, x2, negative 2. So let's write negative 2, 0. Ooh, that's perfect. Look at this. And yeah, if we put positive number, that will be positive, negative, and positive. Okay. Where's that? Is the concave up and concave down? I think it's up, down, up, and concave up will be I hope it's right. What about points? Okay, we will have the coordinates. But first,
So
check.
go ahead and find all of the second derivative. If we differentiate x, That's going to be 2x is 2. X is equal to, and let's pick a test. 12 times number less than negative 2, like negative 3. 12 times blue. We can now add negative 2, and then oh, that's an inflection. So
Okay. Up, through, down, up, down, up.
negative 2 to the 4th power is positive 16.
Thank you very much, brother. I understand this one. Yeah, I understood. Basically, I really understood what does it mean. My teacher advised me, and he's really good. So let's try to do example 4. That's my teacher's example, by the way. E to the power of x minus x squared. Let's find the first derivative. That will be same, that is exception, and x squared will be 2x. E to the power of, yes, this one. And what if it will be equal to 0? Oh my gosh, I'm sorry, I forgot. Oh my gosh, yeah. That must be like this. E to the x minus 2x, that will be 2. And second derivative is 0. I'm real tired. E to the x minus 2, 0. E to the x will be 2. And what about this one? Logarithm? What is this? I don't know. Inflection point. I don't remember logarithms, so I need to learn them. Logarithms. And trigonometric equations. If you plug in, okay, that will be like this. And they are just repetitions. Okay. I think that I understood this topic. That is my calculus notes. They are so much. Okay, thanks for accompanying me. I'm just trying to learn things here and challenge myself. I hope you like this. Ciao.